Hello everyone, welcome to MemoNeet. So this is Aprajita, your chemistry SME. How are you all doing? I hope everyone is doing good and your preparation for BPT10 is going well. So as you know students, the chapter that is going to come is equilibrium. So one more chapter is given there, that is chemical kinetics. Chemical kinetics we have already covered in the last BPT. So if you want to revise that chapter, you can watch the video lectures of chemical kinetics. They are already live on the YouTube. Okay, in the chemistry playlist, go and watch chemical kinetics as well. So in the last session of equilibrium, we discussed about the equilibrium law, equilibrium constant, and the main concept of equilibrium means what is the introduction and everything we discussed. Then we discussed about the law of equilibrium, equilibrium constant, how to calculate it, relation between Kc and Kp. So all of that we covered in the last lecture. So today mainly we will be focusing on the applications of equilibrium constant, ki where all we can use this equilibrium constant, and then we will be discussing various factors that are affecting the equilibrium. That is very important. We will be discussing about the Le-Chatelier's principle. That is important. Okay, so this is all what we will be doing in our today's lecture. So stay tuned till the end because Le-Chatelier's principle is very important. Conceptually also you have to be very strong to answer these questions, and not just in physical chemistry. This Le-Chatelier's principle you must know in all aspects of chemistry. Okay, in organic also you must be knowing about the Le-Chatelier's principle. That's why it is important. Okay. So that's all we will be discussing in our today's lecture. I hope all of you have watched the yesterday's lecture. If you have not watched it yet, please go and watch that first, and then we will be starting with this lecture. Okay. All right. So as I told you, we will be talking about the applications of equilibrium constant. So there are various features of equilibrium constant that we have already discussed in our last lecture. Let us summarize them all. So the expression for equilibrium constant is applicable only when the concentrations have attained constant value at equilibrium state. Means whenever we are talking about the equilibrium constant now, so the concentrations what we are taking, these concentrations must be having a constant value at the equilibrium. If they are not having a constant value at equilibrium, we cannot write the expression for equilibrium constant. Okay, because these are equilibrium concentrations. Then as you know that this equilibrium constant is dependent on the equilibrium concentration, ki what is the concentration of products and reactant and at equilibrium. Okay, but here you have to keep that in mind. It will not depend on the initial concentration, right? Why would it depend on initial concentration if the expression only itself is having equilibrium concentrations? Okay, so it will not depend on initial concentration of reactant and product. Equilibrium constant is temperature dependent. This is very important. You must know that equilibrium constant depends on temperature. So it is having one unique value for a particular reaction at a given temperature. Okay, means with the temperature it is going to change. How it will change, that we will be discussing ki what is the effect of temperature on equilibrium. Okay. Then equilibrium constant for reverse reaction is equal to the inverse of equilibrium constant for forward reaction. That's what we have discussed. Like if for reverse reaction it's Kc dash, so it will be 1 upon Kc. Okay. Then equilibrium constant K for a reaction is related to equilibrium constant of the corresponding reaction whose equation is obtained by multiplying or dividing the equation by a small integer. Means we will be just relating it, right? We discussed na Kc raised to the power n ho jata hai, so that's what it is talking about. So these are some features of equilibrium constant. Now if I talk about the application, so the first application is that the equilibrium constant value helps us to predict the extent of reaction. Now how can we predict the extent of reaction? See, basically we are not getting any information about how, or you can say about the rate at which equilibrium is reached, कि जल्दी equilibrium attain होगा या देर से attain होगा. That's what we are not getting to know from equilibrium constant. Keep that in mind. Okay, so basically हमें यहाँ से पता क्या चल रहा है? You see Kc and Kp values, they are actually directly proportional to the concentration of product. Product is written in the numerator and the concentration of reactants are written in the denominator. So it is inversely proportional to concentration of reactant. So अगर Kc या Kp की value ज़्यादा होगी, more Kc or Kp value will indicate high concentration of product, right? And vice versa, because it is directly proportional. So what do we get to know कि जितनी ज़्यादा Kc या Kp की value होगी उतना ज़्यादा हमारे पास product बना होगा. So there are three cases that you must know. If Kc is greater than 10 to the power 3, this is the first case. तो ये तो बहुत ज़्यादा value, right? It's having a high value. So product predominate over reactant means if Kc is very large, so products will predominate over reactant means reaction will proceed to completion. Okay, means reaction will get completed. All right. Like here you can see the reaction of hydrogen with oxygen has a very large equilibrium constant, so it proceeds to completion. Similarly, reaction of hydrogen and chlorine to form hydrogen chloride gas, hydrogen bromide. So here you can see the equilibrium constant is around 10 to the power 47, 10 to the power 31, 10 to the power 18. So just imagine the concentration of product means this reaction will proceed to completion. But if Kc is very less, means if it is less than 10 to the power minus 3, means if it is very small, okay, so the reaction will proceed rarely, means reaction hoga hi nahi, means here the concentration of reactant will be more, right? Like here you can see the decomposition of water into hydrogen and oxygen at 500 Kelvin has very small equilibrium constant, means वहाँ पर dissociation will be negligible. Okay, it will not happen only. Same goes with the formation of nitric oxide gas. Okay. Now the third case is if the Kc is in this range, right? That is the range of 10 to the power minus 3 to 10 to the power 3. Then what will happen in this case? Like it's up, like here we can say the concentration of reactant and product both will be appreciable. Okay. For example, here hydrogen and iodine react to form Hi, so here Kc is 57. So here it is neither too small, neither too large. So equilibrium mixture will have concentration of both the reactant and product. Okay. So this you must know ki the value of Kc tells us about the extent of the reaction. Okay. Now, predicting the direction of reaction. Now, this is very important. This comes in the exam also. Keep that in mind. So, equilibrium constant helps us to tell in which direction the reaction will proceed. Means, will it move in forward direction or will it move in backward direction? For this, we calculate reaction quotient Q. Now, what is this reaction quotient Q? QC means if we are writing molar concentration. QP means if we are writing partial pressure. It is same. You can see here for this reaction, the QC value is C raised to power C, D raised to power D, and like this. Now you will say ki ma'am, this Kc is also same. If I want to write Kc for this reaction, then Kc will also be same, right? Then what is the difference between the reaction quotient and equilibrium constant? The difference is that these concentrations that we are taking in QC, they are not equilibrium value. It's not necessary that we are taking the equilibrium concentrations. Okay. But it is important कि in equilibrium constant these concentrations are at equilibrium. कि equilibrium पर what is the concentration of reactant and product? If we are using those concentration, then we will be getting the value of equilibrium constant. So this is the difference. Don't get confused. This is the difference. Okay. Now how to compare? If QC is greater than KC, okay, अगर QC की value ज़्यादा है than KC, so you have to remember the reaction will proceed in the direction of reactant, means reverse में, okay, it will go in reverse. You can see क्यों? क्योंकि it want to achieve or attain equilibrium ना, राइट तो QC की वैल्यू कम होना चाहिए यहाँ पर. वो चाहेगा कि द वैल्यू ऑफ QC शुड डिक्रीज. QC की वैल्यू कम होगी अगर रिएक्टेंट्स की कंसंट्रेशन बढ़ेगी. Obviously they are inversely proportional. Formula से समझो कि don't cram it, just try to understand कि if the value of QC is greater than KC but system always want to achieve equilibrium, okay, so system wants कि the value of QC should decrease ताकि it becomes equal to Kc. तो Qc की वैल्यू कम करने के लिए, टू डिक्रीज द वैल्यू ऑफ Qc, द वैल्यू ऑफ रिएक्टेंट्स लाइक द कंसंट्रेशन ऑफ रिएक्टेंट मस्ट इंक्रीज, और वो कब होगी? व्हेन द रिएक्शन प्रोसीड्स इन रिवर्स डायरेक्शन. Okay, try to remember this flow chart, this diagram also. You can make it in your notebooks as well. Now if QC is less than KC, now you see here if the value of QC is less than KC, now same case, we want कि QC बढ़ जाए, the reaction will want that QC should increase so that it achieves equilibrium. अब QC बढ़ने के लिए क्या होगा? प्रोडक्ट की कंसंट्रेशन बढ़नी चाहिए. So प्रोडक्ट की कंसंट्रेशन कब बढ़ेगी? When the reaction will proceed in the direction of product, means in the forward direction. Okay. And if QC is equal to KC, the reaction is already at equilibrium. See, this question can come in exam also. So this is again very important, this application part. Okay. So you must know all these three cases. Now calculating equilibrium concentration. So if I want to calculate equilibrium concentration, see, suppose we know the initial concentration, but we don't know equilibrium concentration. So using the equilibrium constant, we can find out the value of equilibrium concentration. So for that, we need to write the balanced equation. Okay. So we need to write the initial concentration, change in concentration, and equilibrium concentration. Okay, like table banana and all of that. So substitute the equilibrium concentrations into the equilibrium equation. जो equilibrium concentration हमारे पास आई है. Okay, let's take, we say कि x mole has been used or x concentration has been used, that we will be taking. So we will get a quadratic equation and we will be solving it. Then from that we will get the equilibrium concentrations and we can check that also. So अभी इतना समझ नहीं आएगा. We will take an example for that and we will solve it. So I have taken an example here. See, this is your NCERT problem. Okay, so NCERT में जो भी numericals दिए होते हैं, please try to solve them because they will make your base strong. And sometimes questions are directly asked from NCERT. Okay. So keep that in mind. So here we are having 3 mole of PCl5. It is kept in 1 liter closed reaction vessel. It was allowed to attain equilibrium at 380 Kelvin. Calculate composition of mixture at equilibrium. कि equilibrium पे क्या composition है, means we need to find the equilibrium concentration. So you know कि when PCl5 decomposes, okay, so it gives you PCl3 and chlorine. Okay, so the concentration, if I write, so we have to write two concentrations, initial and at equilibrium. So initial concentration, see, 3 moles is given na, and it is in 1 liter. So if I divide 3 by 1, so kitni aayegi? 3 mole per liter. Okay, so I will just directly write 3 because the volume already is given 1, no? So number of moles per unit volume is concentration. So initial is 3 and initially we only have the reactant. So the concentration of product is 0. Now you see कि equal moles है, 1 moles ही है. So let's say if at equilibrium we are having x moles of PCl3, तो x moles of chlorine ही होगा. Means how much PCl5 has decomposed? तो PCl5 कितना बचेगा? It will be 3 minus x, right? So 3 minus x बचा क्योंकि उसमें से x moles जो है, x या इतनी concentration जो है, that has been decomposed. Okay, उतना decomposition अभी हो चुका है. So at equilibrium we are having 3 minus x, x and x. Now we know the value of Kc, which is given 1.80. Up according to the equilibrium law, what will be the expression for Kc? Concentration of PCl3, concentration of chlorine divided by concentration of PCl5. Just put the values 1.80. Here x into x divided by 3 minus x. So now just cross multiply it. So it will be 1.80 into 3 minus x and here you will get x square. I told you na, you will be getting a quadratic equation that you have to solve. So यहाँ पर कितना आएगा? 5.4 minus 1.8x equals x square. So from here x square plus 1.8x minus 5.4 equals 0. So you have to solve this quadratic equation now. So from here you will be solving it and you will be getting the value of x. Okay. So students, since you are not from maths background, maybe some of you can be. So you know that if I'll tell you यहाँ से x की value आएगी 1.59 molar. Okay, so the concentration of PCl5 would be 3 minus x, which is 3 minus 1.59, which is 1.41 molar. Okay, and concentration of PCl3 and chlorine would be like equal to, you can say both the concentrations are 1.59 molar at equilibrium. So this is the composition of mixture at equilibrium. So see, I have explained that application using an example. Okay, and yeah, one more thing, if you have how to solve this quadratic equation. So if you have any quadratic equation like ax square plus bx plus c equal to 0. So if you want to calculate the value of x, it will be minus b plus minus square root of b square minus 4ac upon 2a. So this is the formula that you are going to use, and here we will be using the same formula. X square plus 1.8x minus 5.4. So here you will be writing b is minus like it's 1.8 plus minus means two roots will be calculated. 1.8 square minus 4, a is 1, c is minus 5.4. okay, and 2 into 1. So you will be solving it, and the value will you have to take only the positive value here. Okay, so it will be 1.59 molar. Okay, so this was about the applications. Now we will be studying the relationship between the equilibrium constant and the Gibbs free energy change. So I hope now the applications are clear. How can we find out the equilibrium concentrations? We have taken an example for that. Okay, so now the next thing is relationship between equilibrium constant, reaction quotient and Gibbs energy. So students, we have studied about Gibbs energy in the thermodynamics. So you know the value of Kc for reaction does not depend on rate of the reaction, but it is directly related to the thermodynamics of the reaction, means it will be directly related to the delta G, which is the Gibbs free energy change. So we have already studied कि if delta G is negative, so the reaction is spontaneous, means it will proceed in the forward reaction or forward direction. Now we know कि if the delta G value is positive, the reaction is considered non-spontaneous. Okay, means reaction will not proceed in forward direction. But you know कि अगर forward direction के लिए delta G positive है, then for the reverse reaction the delta G would be negative. It means that in that case reverse reaction would be favorable. Okay, so if delta G is positive, so reverse reaction would be favorable, means the products will be converted back to the reactants. Okay, and you know if delta G is 0, means reaction has achieved equilibrium. At this point there is no longer any free energy left to drive the reaction. Okay, so the mathematical expression that we'll be taking is delta G is delta G naught plus RT log Q. Q is our reaction quotient that we have just discussed. G naught is the standard Gibbs energy. Okay, so remember this expression, delta G is equal to delta G naught plus RT log Q. It can be used to ask the numericals also. Okay, so at equilibrium, now we have discussed कि equilibrium पर the delta G value is 0. So if delta G is 0, then delta G naught will be equal to minus RT log up. Now we are talking about equilibrium, so you know कि equilibrium पर this Q will become Kc. Right, you know कि at equilibrium Q is equal to Kc. So instead of Q we will be writing Kc. So minus RT log Kc or K, and from here we can say log Kc or log K will be delta minus delta G naught upon RT. Now here you will be taking anti-log, you will take anti-log, so यहाँ से क्या आ जाएगा K, and if you take anti-log here it will go into the exponent, so e raised to the power minus delta G naught upon RT. So this relation also you must know. Okay, so in the terms of delta G naught means standard Gibbs energy change के terms में we can tell about the reaction spontaneity. If delta G naught is negative, okay, so अगर देखो this term is already negative ना, if delta G naught is negative, so this whole term will become positive, right? If this whole terms become positive, so it means ये जो आपका factor है e raised to the power minus delta G naught upon RT would be greater than 1, so means K will be greater than 1. So K is greater than 1 means it's a spontaneous reaction or the reaction which proceeds in a forward direction. So if delta G naught is negative, K will be positive and the reaction will be spontaneous. Okay. And same goes with the reverse. Agar delta G naught is positive, so then this term will remain negative only. For that means K value will be negative, less than 1. And if it is less than 1, it is a non-spontaneous reaction. Okay. So means only a small minute, you can say minute quantity of the product would be formed. So this is the relationship that you must know. Okay. Now the next and very important thing is the factors affecting equilibria or your Le-Chatelier's principle. So we know कि जो equilibrium constant है Kc, it is independent of initial concentration. Okay. But obviously if we what we are doing is ki if a system which is present at equilibrium, let's say if I am having this reaction, now this system is at equilibrium, but if I change the equilibrium, means jab equilibrium achieve ho gaya, now what I do, I add more amount of A. Okay, I add more amount of reactant A to it. Now if I am adding more amount of reactant A to it, या A क्या एक से ज़्यादा मैं reacting substance या B भी और डाल दूँ, so what will happen? Now the system will not be at equilibrium. Okay, अब if now the system is not at equilibrium, but you know कि system wants to be at equilibrium again, so means कुछ होगा. Now when I am adding A, something would happen so that the system will return to equilibrium again. Similarly, if I change the temperature or pressure, that will also affect the equilibrium. Okay. Now what that like that thing कि अब क्या होगा, I told you ना कुछ होगा, like reaction will happen. So क्या होगा वो discuss करने के लिए we have Le-Chatelier's principle कि if we are changing any concentration, any temperature, pressure, so how the system will react to that change to achieve the equilibrium, that is our question. So Le-Chatelier's principle states that any change or a change in any of the factors that determine the equilibrium conditions of a system will cause the system to change in such a manner so as to reduce or counteract the effect of change. Now what does that mean? Let's try to understand it. I'm taking an example of same reaction A plus B gives C plus D. हम सारे factors अलग अलग discuss करेंगे. I'm just trying to explain you the Le-Chatelier's principle. Now let's say this system was at equilibrium and I have added more reactants. Okay. More reactants means I have added some amount of A and B to that reaction mixture. Now equilibrium is disturbed. So according to Le-Chatelier's principle, the system will change in such a manner so as to counteract the effect of change. Ab yahan par what was the change? What was the change that I did? I added more reactants. So system will or you can say act or change in such a manner कि ये change reverse हो जाए, means it will try to reduce the concentration of reactants. I have added more reactants, so system will act opposite to it. It will want to reduce that concentration of reactant ताकि फिर से equilibrium आ जाए. अब concentration of reactant कैसे reduce होगी? जब वो react करके product बनाएंगे, right? तो in that way the reaction will move in forward direction. Try to understand this. Okay, so the reaction will move in forward direction. So kuch bhi hoga, like say if I am increasing the temperature, let's say if I am increasing the temperature, so the equilibrium will change in such a way to reduce temperature. वो उस चेंज को अपोज करना चाहेगा, राइट? इट हैज अ टेंडेंसी टू अपोज दैट चेंज कि अगर हम टेम्परेचर बढ़ा रहे हैं तो सिस्टम डजंट लाइक इट. ओके, जस्ट try to understand in this way कि whatever change we are doing, the system is not liking it, so system wants to reverse that change. Okay, it is giving you back. So if you are increasing the temperature, system will change in such a way ताकि वो temperature reduce हो जाए फिर से. Okay, means वो temperature absorb हो जाए, मतलब endothermic की तरफ वो change हो जाएगा. That we will see. Similarly, अगर मैं product की concentration बढ़ा दूं, सो सिस्टम वांट्स कि प्रोडक्ट की कंसंट्रेशन कम हो जाए, मींस बैकवर्ड रिएक्शन हो जाएगा वहां पर. ओके, सो दैट इज Le-Chatelier's प्रिंसिपल कि द any change in that factor will cause the system to change in such a way so that it counteracts the effect of the change. Okay, usko oppose kare, it will oppose that change. Okay, I hope this is clear. Now we will discuss separate factors. First is effect of concentration change. Okay, like I have just explained you, Le-Chatelier's principle predicts that concentration stress of any added reactant and product is relieved by net reaction in the direction that consumes the added substance. Of course, कि अगर मैं reactant add करूँगी, so the reaction will proceed in that direction जहाँ पर reactant consume हो, and if I am adding some product, so reactant will move in that direction जहाँ पर product consume हो. Okay, but मैं निकाल भी तो सकती हूँ. I can remove also, right? So if I am removing any reactant, okay, so the direction, system will move in that direction जहां पर वो reactant फिर से बन जाए, means in the backward direction. Okay, and if I am removing a product, okay, continuously कई बार क्या होता है in some reactions we are continuously removing the product, वो हम product remove करते रहते हैं, तो system wants कि product और बनता रहे, it want to replenish the product, तो वो reaction forward direction में proceed करता रहेगा. Okay, to get better yield we use this. Okay, I hope this is clear. So let's try to understand it with an example. Let's say if I'm having this reaction, hydrogen plus iodine gives hydrogen iodide. If I am adding hydrogen to the mixture which is at equilibrium, so equilibrium is disturbed now. Okay, now system will want to restore it, so I have added hydrogen. तो system wants to restore it. अब system restore कैसे करेगा? It will shift in a direction where hydrogen is consumed, right? Because उसको तो oppose करना है, right? It want to oppose the change. So if I am, so it will shift in such a direction where hydrogen is consumed. तो hydrogen कौन सी direction में consume हो रही है students? In the forward direction, right? So it means the system will shift in, or the equilibrium will shift in the right side, means the forward direction, क्योंकि hydrogen और iodine react होंगे and they will form Hi, means hydrogen iodide. So this is in accordance with the Le-Chatelier's principle. Okay, so that is what effect of concentration change will be. All right, now let us talk about the general thing. So if you are adding the reactant, okay, so try to understand the system will shift to reduce the concentration of reactant. Okay, concentration of reactant. तो reactant की concentration कहाँ पर reduce होगी? In the forward direction. So this is a flow chart, means you have to remember this कि the system will shift in the forward direction. But if I am adding product, okay, try to understand, if I am adding product, so the system will shift or equilibrium will shift to reduce the concentration or amount of product. तो प्रोडक्ट का अमाउंट कैसे कम होगा? अगर वो रिएक्टेंट में फिर से कन्वर्ट हो जाए, मींस द सिस्टम विल शिफ्ट टू द लेफ्ट हैंड साइड और द इक्विलिब्रियम विल शिफ्ट इन द बैकवर्ड डायरेक्शन. So this is very important, keep that in mind. Okay, now we will be discussing the next change. Okay, see, before pressure change, the thing is कि you can explain it in terms of reaction quotient also. Like if you are adding hydrogen, so यहाँ पर देख लेते हैं. So for reaction quotient, here reaction quotient will be Hi raised to the power 2 and H2 and I2. Okay, so if you are adding hydrogen, अगर hydrogen का amount बढ़ रहा है, so what will happen to QC? QC will decrease. Okay, so now QC, earlier QC was equal to equilibrium constant, now QC is less than equilibrium constant. Okay, so if QC is less than equilibrium constant, you know what will happen? The system will shift in forward direction, but because it would like to be equal to Kc, और वो equal कब होगा? अगर product की concentration बढ़ेगी, means it will shift in forward direction. That's what we have just discussed. Okay, so according to Le-Chatelier's principle also, or according to QC also, you can tell this. Okay, so that is the thing. All right, तो लाइक आई टोल्ड यू कि रिमूवल ऑफ प्रोडक्ट ऑल्सो बूस्ट द फॉरवर्ड डायरेक्शन. अगर हम प्रोडक्ट रिमूव कर देंगे सो सिस्टम वांट्स कि और प्रोडक्ट बने, तो और प्रोडक्ट कब बनेगा? इफ द इक्विलिब्रियम शिफ्ट्स इन फॉरवर्ड डायरेक्शन. तो इसीलिए इन लाइक industrial manufacturing sometimes we keep on removing the product. Like here, you know, in the manufacturing of ammonia, ammonia is liquefied and removed from the reaction mixture. उसको साथ के साथ we remove so that the reaction keeps moving in forward direction. Okay, similarly in the production. So in the case of calcium oxide, so when we are preparing it from calcium carbonate, constant removal of carbon dioxide from the kiln drives the reaction to completion. So all that is happening because of the LeAter's principle. Okay, so again if we are removing the product, so again जो QC है it will be lower, it will be having less value than KC and it will move in the forward direction. Now effect of pressure change, again very important. So again if we are talking about pressure change, so a pressure change obtained by changing the volume can affect the yield of product. तो pressure कैसे change होगा? If we change the volume. Okay, so why? Because the total number of moles of gaseous reactants and total number of moles of gaseous products are different. So we will be here considering about the number of moles of gaseous reactants and products. So we will be counting that. Now how in that case the effect of pressure change on solid and liquid, we will be ignoring it because you know that volume of a solution or liquid, it is independent of pressure. In solids or liquids के case में pressure का कोई काम नहीं है. We are only considering for gases. Okay, so how it is going to change? Let's take an example. So here the example is, here 4 moles of reactants. Okay, total like reaction देखो, carbon monoxide plus 3H2. So number of moles of gaseous reactants कितने हैं? Gaseous reactants, how many are there? 4. Okay, and total number of gaseous products कितने हैं आपके पास? 2 moles है ना, 1 mole methane and 1 mole of water. Now if we are having this equilibrium mixture, it is kept in cylinder fitted with a piston which is at constant temperature. Now if I am compressing it to 1/2 of the volume, okay, so if I am reducing the volume to 1/2, obviously the pressure would be doubled. Okay, now what will happen if the pressure is getting doubled? How the equilibrium will change? Now if the pressure is double, you know the concentration of reactants and products have changed and the mixture is not at equilibrium. Okay, so how it will shift? Let's see according to the LeAter's principle. Now the pressure has doubled, so equilibrium shifts in the forward direction. Now why? Why it is so? Because when the pressure has been increased, system wants कि अब प्रेशर कम हो जाए, राइट? सिस्टम विल शिफ्ट इन सच अ वे टू रिड्यूस द प्रेशर. एंड प्रेशर कहाँ कम होगा? सो यू नो कि जितने ज्यादा नंबर ऑफ मोल्स ऑफ गैसेस होंगी, बिकॉज प्रेशर इज डायरेक्टली प्रोपोर्शनल टू नंबर ऑफ मोल्स, सो जितने नंबर ऑफ मोल्स ऑफ गैसेस होंगे उतना प्रेशर ज्यादा होगा. नाउ सिस्टम वांट्स टू रिड्यूस द प्रेशर, तो सिस्टम विल शिफ्ट इन सच अ डायरेक्शन वेयर द नंबर ऑफ मोल्स ऑफ गैसियस substances is less. So you know in the product side the number of moles are less, so that's why the system will shift or equilibrium will shift in the forward direction. Okay, so that is the thing. Now you can understand it using QC also. If I write QC, these are the molar concentrations. Okay, when the volume of reaction mixture is half, the partial pressure and concentration are doubled. Of course ki pressure bhi double hoga and concentration will also be double because they are directly proportional. Okay, so if we अब हमें क्या करना है? to replace, if we want to obtain the reaction quotient, so we will be replacing it by double its value. अब यहाँ पर हो क्या रहा है? the concentrations are getting doubled, so it means QC is less than KC. If QC is less than KC, the reaction proceeds in the forward direction. Okay, now in this particular reaction यहाँ पर देखो C plus CO2 gives 2CO. When pressure is increased, अब pressure increase कर रहे हैं तो system wants कि pressure कम हो जाए. अब pressure कम किस तरफ है? जहाँ पर lesser number of moles हैं. Okay, अब lesser number of moles of gases है, तो यहाँ पर देखो ये तो solid है, ये तो count नहीं होगा. So lesser number of moles किस तरफ है? reactant वाली side. So reaction will move in the reverse direction. Okay, So how can we generalize it? So if we increase the pressure, what will happen? Please note this flowchart. This is very important. So that will help you to generalize. If we increase the pressure, equilibrium will shift to reduce the pressure. Right? So equilibrium कैसे shift करेगा ताकि pressure कम हो जाए. So pressure कम कब होगा? It will shift in the direction of fewer number of gaseous moles. कि जहां पर lesser number of gaseous moles होंगे. Okay, but if I am decreasing the pressure, pressure decrease भी हो सकता है. How? By decreasing, okay, by increasing the volume. अगर हम volume increase कर दे तो pressure कम हो जाएगा, right? So equilibrium will shift to increase the pressure. Now increase कब होगा? How will the pressure increase? The pressure will increase, though the system will shift to the direction where you have more number of gaseous moles. So जितने ज़्यादा moles होंगे उतने ज़्यादा pressure होगा, right? So this is for pressure. So I am giving you these flow charts for everything. Okay. So next factor, students, inert gas addition. So you know कि if the volume is kept constant and inert gas such as argon is added, it will not take part in the reaction. Equilibrium remains undisturbed. Because addition of inert gas at constant volume, it does not change the partial pressure or molar concentration. If the partial pressure and molar concentration does not change, the equilibrium constant will not change. Okay. तो रिएक्शन कोशेंट कब चेंज होता है? ओनली इफ द एडेड गैस इज अ रिएक्टेंट और प्रोडक्ट. अगर हम एक इनर्ट गैस डाल दें, इट विल नॉट अफेक्ट. अगर वो रिएक्टेंट या प्रोडक्ट में से कोई एक है तब वो चेंज होगा, अदरवाइज नॉट. ओके, नाउ द नेक्स्ट इज योर टेम्परेचर. वेरी इंपॉर्टेंट. अगेन टेम्परेचर चेंज. ओके. So now you know कि when equilibrium is disturbed by change in concentration, pressure और volume, composition changes क्योंकि QC change हो जाता है. It no longer equals the equilibrium constant. But वहां पर इक्विलिब्रियम कांस्टेंट चेंज नहीं हो रहा था. द वैल्यू ऑफ क्यूसी वाज चेंजिंग. ओके, बट व्हेन अ टेम्परेचर चेंज हैपेंस, अब टेम्परेचर अगर चेंज हो रहा है, सो यू नो कि इक्विलिब्रियम कांस्टेंट डिपेंड्स ऑन टेम्परेचर. सो व्हेन टेम्परेचर चेंज इज हैपनिंग, इक्विलिब्रियम कांस्टेंट विल चेंज. ओके, सो अब first of all try to understand ki how equilibrium constant changes with temperature. Okay, that is very important. All right, now equilibrium constant for exothermic reaction. Okay, अब exothermic reaction के लिए जो equilibrium constant है, exothermic reaction means negative delta H where heat is released. Okay, so in an exothermic reaction अगर हम temperature बढ़ा रहे हैं, okay, if I am increasing the temperature in an exothermic reaction, so the equilibrium constant will decrease. Okay, and द इक्विलिब्रियम कांस्टेंट फॉर एंडोथर्मिक रिएक्शन. अगर आपके पास एंडोथर्मिक रिएक्शन है तो टेम्परेचर इंक्रीज करने पर आपका इक्विलिब्रियम कांस्टेंट भी बढ़ जाएगा. व्हाई? दैट वी विल जस्ट डिस्कस. क्योंकि टेम्परेचर इंक्रीज करना फेवर्स एंडोथर्मिक रिएक्शन ऑलवेज. if you are increasing the temperature, तो according to LeAter's principle it will favor endothermic reaction. कैसे? Let me tell you. देखो, if you are increasing the temperature, all right, so what will happen, students? System will shift or equilibrium will shift to reduce the temperature. Of course oppose करेगा वो, right? So system will shift to reduce the temperature. अब temperature reduce कैसे होगा? अगर जो हम temperature दे रहे हैं, if we are increasing the temperature, वो सारी heat absorb हो जाए. Okay, heat absorb कौन से reaction में होती है? Endothermic में. So it will shift in such a direction जहाँ पे आपका endothermic reaction हो रहा. So students, you know कि अगर if you have any reaction, okay, and if the forward reaction is endothermic, so you must know कि the backward reaction would be exothermic. ओके, सो इन दिस केस अगर मैं इसी रिएक्शन की बात करूं, अगर इन लेट्स सपोज इस रिएक्शन में आई हैव इंक्रीज्ड द टेम्परेचर, तो system will or equilibrium will shift to reduce the temperature. reduce temperature कब होगा? जब वो heat absorb हो जाएगी. means here in this case it will shift in the forward direction because forward direction is endothermic. okay, similarly if we are decreasing the temperature, all right, so decreasing the temperature, अब system क्या चाहेगा? it wants to shift in a direction to increase the temperature. all right, so system wants to increase the temperature, and that temperature increase कब होगा? when the system will shift in the direction of exothermic reaction, because exothermic reaction is the one that releases heat. please note that also. and here it absorbs heat. अगर वो heat absorb कर लेगा तो temperature low हो जाएगा, right? so in the same reaction only, अगर मैं temperature decrease कर दूँ, all right, so you know कि backward process is exothermic, so the system will shift in exothermic backward direction. इसीलिए हम कह रहे हैं कि if we are increasing the temperature for endothermic reaction, so equilibrium constant would increase, but if you are increasing the temperature for exothermic reaction, so equilibrium constant would decrease. okay, so equilibrium constant varies with temperature, because you know temperature increase always favors the endothermic reaction. तो वहाँ पर equilibrium constant बढ़ जाएगा, and for exothermic reaction it will decrease. okay, like for here we have taken example of ammonia. so it's an exothermic process. forward direction मतलब formation of ammonia is an exothermic process. delta H is negative. so if you are increasing the temperature, if you are increasing the temperature, तो system कौन सी direction में shift होगा? it will favor the endothermic reaction. और endothermic कौन सा है आपका? backward. here in this case it is the backward reaction or the reverse reaction. so the equilibrium will shift to the left hand side, means it will decrease the concentration of ammonia. okay, अगर ammonia की concentration decrease होगी, of course यहाँ पर आपका जो इक्विलिब्रियम कांस्टेंट है वो डिक्रीज हो जाएगा, राइट? बिकॉज इक्विलिब्रियम कांस्टेंट वुड बी NH3 स्क्वायर N2H2 क्यूब. So that's what I'm telling you कि if this is an exothermic process, you are increasing the temperature, तो equilibrium constant is decreasing. okay, because it will favor the backward direction. so in this case what we know, तो यहाँ से हमें क्या पता चल रहा है कि अगर हम टेम्परेचर बढ़ा रहे हैं, it is favoring the formation of reactants. तो it means for formation of ammonia, low temperature is required for high yield. okay, but if we use low temperature, तो वहाँ पर like it is not favorable. okay, तो रिएक्शन बहुत ही स्लो हो जाता है, एंड इंडस्ट्रियल प्रोसेस में इट इज़ नॉट फेवरेबल, सो हम उसको फास्ट करने के लिए कैटलिस्ट यूज़ करते हैं. ओके, सो आई होप दिस इज ऑल्सो क्लियर. So LeAter's principle is very important, and last but not the least is catalyst. So you know कि we have studied in chemical kinetics कि catalyst increases the rate of chemical reaction by giving a low energy pathway. okay, so it will increase the rate of forward reaction and reverse reactions that pass through the same transition state, but it does not affect the equilibrium. okay, so it is not affecting the equilibrium, it will just lower the activation energy for forward and reverse reaction by the same amount ताकि equilibrium जल्दी achieve हो जाए. okay, it is not affecting the equilibrium composition because it is not participating in the reaction. if it is not participating in the reaction, it will not affect the equilibrium composition. okay, so in the case of ammonia, you know it proceeds with decrease in number of moles. तो डिक्रीज इन नंबर ऑफ मोल्स को कौन फेवर करेगा? हाई प्रेशर. ओके, सो इट्स एन एक्सोथर्मिक रिएक्शन एंड इट प्रोसीड्स विद डिक्रीज इन नंबर ऑफ मोल्स. सो इक्विलिब्रियम कांस्टेंट हियर डिक्रीजेस विद इंक्रीज इन टेम्परेचर. ये अभी हमने डिस्कस किया कि टेम्परेचर बढ़ाने पर इक्विलिब्रियम कांस्टेंट कम हो रहा है बिकॉज इट्स एन एक्सोथर्मिक प्रोसेस. लो टेम्परेचर पर रेट कम हो जाता है, तो इट टेक्स लॉन्गर टाइम टू रीच इक्विलिब्रियम. तो क्या यहाँ पर यूज करना पड़ता है? वी यूज catalyst. Okay, catalyst use करते हैं and where we get a good yield of ammonia because it's an industrially driven process. तो हमें yield यहाँ पर ज़्यादा ज़रूरी चाहिए होती है. Okay, and यहाँ पर you know that N2 plus 3H2 gives 2NH3. So forward direction में you have fewer number of moles. So increase in pressure will also favor the forward direction. Pressure increase करेंगे तो fewer number of moles की तरफ वो move करेगा. Alright. So students, this was related to the effect of various changes or factors affecting equilibria, where we have discussed the Le-Chatelier's principle. So this is very important. Try to understand it. Okay, जो भी हमने factors पढ़े, the concentration change, temperature, pressure change, they are very important. So based on that, examples will be asked, and based on that you will be getting the questions. Okay, so if you are having any doubts, you can comment us in the group, also in the Telegram channel, or in the comment section in YouTube also. So make full use of these things. So if you are having any doubts, you can ask us anytime. All right, and we'll be more than happy to help you all. Okay, so one last topic for this chapter is left, which is very important. So we were discussing chemical equilibrium till now. So in the next topic lecture, we will be discussing the ionic equilibrium, where we will be talking about acids and bases, pH, and all of that. Okay, so that is again an important lecture, so do not miss that as well. So for today, this is it. Thank you so much. Bye bye.